Everyone, good morning. Welcome to Infinity Learn by Sri Chaitanya. Right. So hope all of you are almost ready for JEE Main exam 2025. So dear students, you know well in the last minute preparation you must be doing. So be comfortable, nothing to feel tension. We are still having 2 comfortable weeks. But dear students, in the last minute revision, I'd like to give an analytical way of approach for this JEE math preparation part. I think you know, my dear friends, this is Bashir, math faculty at Infinity Learn by Sri Chaitanya. Right, dear students? So now today's topic is, beforehand I'd like to say, even though in math around 25 to 27 topics are in the JEE, there are certain topics which are being taken with maximum weightage and the questions are comparatively easy and the topics are also bit not lengthy. Such topics I have taken. So the series title is, dear students, 60 minutes wala session, 10 classes, you are going to score 60 marks. If the paper is tough, 60 marks would give you 99.5 percentile. The paper is moderate, 60 marks will give you 99 percentile. The paper is easy, maybe 98.5 percentile in mathematics, right? So dear students, are you all ready to follow the class? Ready, dear students? Fine. Chalte hain. You see, that's what I've written. Today's topic is binomial theorem. You know, binomial theorem topic is almost independent topic. Independent because you don't require much of, say, calculus, much of geometry, algebra, simplifications related only. Such a beautiful topic, independent topic binomial theorem is. So, in my view, in the list of all the 10 topics, the first topic in my view is binomial theorem. Okay. Yeah, Shashank More will help you, don't worry. I'm here to help you, dear students. This 60 minutes wala session will give you a beautiful insight over the topic and you just follow whatever I am saying. Definitely you are going to crack, dear students. Right? So, binomial theorem. This is a very, very important part. So, I have taken altogether around 120 questions, previous year question. That means all JEE main questions starting from 2010 to 2024, there are 120 questions almost. So, I have classified into various models. You see, general term in binomial theorem, just if you know the general term in binomial theorem, you can answer 19 of those 120 questions. Then, coefficient of x power n model, there are 35 questions, that is almost 30%, dear students. Almost 30% of the questions on coefficient of x power m, dear students. Yeah. So, like to say here, fine. Yeah. So, 35%. Similarly, I have written here, you see, this particular pie chart is going to help you a lot to understand the PYQs from the chapter binomial theorem. You see, the white wala, 29% of the questions are taken by coefficient of x power n model, and coefficient of x power n in products kind of questions, that is a little bit higher model, there you got 13 questions. Altogether, these two models together, 40% of the questions are from these two models only, 40%. Then just if you know binomial theorem, finding nth term or TR plus 1, if you know basic binomial theorem statement, 16% of the questions can be answered. So my dear friends, altogether you can say 29, you see, that is also 29, almost 58% of the questions are from these three only. Generally in the class even we also highlight many questions, many models, lengthy, difficult, but you see almost 60% of the questions here, and remainder model questions there are 22, that is 18%. That means, my dear friends, if some student is feeling binomial theorem is very difficult, I cannot do because many models are there. If you focus on these 4 models at least, you see almost I can say 70% of the questions are covered in the previous model. Only 4 models are majorly important, dear students. First one is binomial theorem just nth term. Second one, coefficient of x power n direct questions. coefficient of x power n products, remainder model. These take the major one. Then dear students, you can see number of rational terms, 5 questions, simple properties of binomial. So somewhere many people are saying that properties of binomial quotients are not there in the syllabus, but in 2024 also we got questions from binomial theorem. So I mean properties of binomial coefficients. So you can take these two, granted they are there for even for 2025, and miscellaneous some 1 or 2 questions, dear students. Okay, so this is the flow chart. So what do you say, dear students? Is it helpful to you to understand the topic? What are the important subtopics? Do you understand? Do you understand, Shashank? So where are the important questions? So you need to focus more on these 4 topics first, then rest of the, if based on your interest and time, you can focus here. Of course, we can't say that the questions will be from this model only, but there is a probability is more to get question from this area, right? Then next, my dear friends, coming to binomial theorem. So what is the first point that you need to learn? So first model problems I am going to explain here. So first point is, in a binomial, in the sense, if you take x plus y whole power n, where n is a positive integer, so you know its expansion will be like nc0 x to the power of n minus 0 y power 0 plus nc1 x to the power of n minus 1 y power 1 plus and so on. General term will be ncr into x to the power of n minus r into y to the power of r, and so on. The last term ncn into x power 0 y power n. This is what we call binomial theorem for natural number index or positive integral index. You know there will be n plus 1 term. My point is, in this expansion, what is tr plus 1? The point is, what is r plus 1th term in a binomial expansion of x plus y whole power n? This point alone is very, very important, enough to answer around 20% of the PYQs, dear students. What is tr plus 1, dear student? Tr plus 1 is nothing but ncr into x to the power of n minus r into y to the power of r. You know, ncr is a binomial coefficient. This will be. At the same time, if you take like 1 plus x whole power n expansion, you will simply get like nc0 plus nc1x plus nc2x square and so on ncn x power n. Okay. So with these 2 simple points, we shall start certain PYQs, dear students. You see, the first question, it is given here. Let m and n be the coefficients of 7th and 13th terms respectively in the expansion. Find n by m whole power 1 by 3. This is the question, dear students. He has given a binomial expansion. He said coefficients of m is the coefficient of 7th term and n is coefficient of 13th term. So their ratio. First let us try to find m, dear students. M is nothing but the coefficient of, you see, the coefficient of 7th term. 7th term, how will you write? 18c6, you just want coefficient, no need to take x. 1 by 3 power 18 minus 6 is 12 into 1 by 2 power 6. This is m, right? Then n is nothing but the coefficient of 13th term, that is 18c12 into 1 by 3 power 6 into 1 by 2 power 12. Fine. Now, dear students, he wants n by m. Let us find m by n. M by n, you divide. You see 18 by 6 and 18c12 both are the same. Cancel. Here you will get 1 by 3 power 6 by 1 by 2 power 6, which is 2 by 3 whole power 6. So this is m by n. So n by m will become 3 by 2 whole power 6, whole power 1 by 3 is there. So which is 9 by 4 is the answer. So 9 by 4 is the answer, dear students. Got it? So dear students, I mean to say a simple, to answer this question, it is the latest PYQ only. What you need to know is just tr plus 1. Okay? Simple. Second point, second question, you see, dear students, this question here, alpha and beta be the coefficients of x power 4 and x square respectively. In this expansion, it is combination of a plus b whole power 6 plus a minus b whole power 6. You know, my dear friends, if you write expansion here, you will get 7 terms here, 7 terms here after addition. So, second term, fourth term gets cancelled. The expression will give you twice of first term, 6c0 term, where x power 6 minus 0 into this power 1. Then x 6c2 into x power 4 into root of x square minus 1 whole square will give you x square minus 1. Then 6c4 into x power, you see, x power 6 minus 4, 2 into x square minus 1 whole square you will get, plus 6c6 into x power 0 x square minus 1 whole cube you will get. If you know this point, dear students, this is simple. So, a plus b whole power n plus a minus b whole power n, if you write the binomial coefficients, binomial expansion, so alternate terms gets cancelled, twice of first term plus third term plus fifth term, like that you will get. Now, you need to catch the coefficient of x power 4, which is nothing but alpha, coefficient of x square, which is nothing but beta. So, try to find alpha, my dear friends. Coefficient of x power 4 I want. So, twice of it is x power 4 coefficient will not be here. Here you will get minus 6c2 into 1. Here, if you expand this, you will get x square minus x power 4 minus 2x square, that is minus 2 into 6c4. And if you expand here, this is 1, x power 6 minus 3 x power 4, this is minus 3 you will get. So, which is, my dear friends, 6c2 is 15. So, minus 48 into 2 minus 96. Okay. Then beta is nothing but the coefficient of x square. Catch coefficient of x square, it will not be here, it will not be here. Here you will get, if you expand x power 4 minus 2x square plus 1, so you will get twice of 6c4, and here also you will get plus, here minus 3x square you will get, that is minus 3 here. Okay. So, this is going to be, dear students, 6c4 will become 15 minus 3, correct. You see here, this is x power 4 minus 3 x power 4, I mean x power 6 minus 3 x power 4 plus 3x square, this is plus 18 into 2, 36. Now, alpha beta, you know, he is asking to check alpha plus beta, alpha minus beta. Alpha plus beta is a negative quantity, that to minus 60, these two options will go. Alpha minus beta will be a negative quantity, minus 96 minus 132, correct. Option D is the right answer. To answer this question, dear students, I mean to say, what you need to know is just binomial theorem expansion is enough, remaining all algebraic simplification only. Okay, dear students. The next, you see this question, if 1 plus x power 4 plus x power 5 is this binomial expansion, you see 1 plus x power 4 plus x power 5 is equal to, this is if you put I is equal to 0, a naught 1 plus x whole power I plus a1 1 plus x plus a2 1 plus x whole square and so on, you will get a5 1 plus x whole power 5. In this, I just want a2 coefficient I want. So, we shall do one thing, my dear friends, let us replace x by t minus 1, so that this becomes 1 plus t minus 1 whole power 4 plus t minus 1 whole power 5 is equal to, you will get a naught, if you put t minus 1, this becomes a naught plus a1 plus a1 t square plus and so on a1 t power 5. So, my dear friends, in this expansion, you see a1 t plus, so I mean to say a2 is nothing but t square coefficient, a2 is nothing but t square coefficient. So, t square coefficient, what will you get here? So, 4c2 into t square, am I correct, into minus 1 power 2, and here plus 5c2 in 5c3 into t square into minus 1 power 3, right. This is going to be a2, my dear friend, t square coefficient, a2 t square it is. Now, it is going to be 4c2 is 6 minus 5C3 is 10 is going to be A2. So A2 value is minus 4, dear students. Minus 4 is the answer. So in this expansion also, to answer this question, what you need is just binomial theorem expansion. That's it. The next, dear students, you see this question seems to be very lengthy, difficult. When we read this question, generally we feel this is bit, we cannot answer. But this, you see, let the sixth term of this binomial expansion in the increasing powers of the second one, okay, be 21, right? If the binomial quotients of the second, third, fourth terms in the expansion are respectively first, second, fifth terms of an AP, then the sum of squares of possible values of x he is asking. So dear students, here I mean to say this is like a plus b whole power m. He wants, he is increasing in the same order, he is increasing. The sixth term is 21. How do you write sixth term, my dear friends? Sixth term means power is m, mc5 into x to the power of m minus 5. You see, number power logarithm, this is 3 power x, my dear friends. Number power logarithm, so this is 10 minus 3 power x, under square root is there, power m minus 5. This is power m minus 5 by 2 into second one power 5, you will get, this is 2 power, you see, you can write here, this x minus 2 can be taken to the power, number power logarithm is there, this is 3 power x minus 2. This is 3 power x minus 2, power 1 by 5 is gone. So this value is given as 21, my dear friends. So here one interesting point is, by observation, MC5, this is 7 into 3. So one of the numbers must contain 7. So why don't we try m is equal to 7 by trial and error. So if you take m is equal to 7, 7c5 into 10 minus 3 power x power, 7 minus 5 by 2 will become 1, 3 power x or 3 power x by 9, this is 9 into 21. So 7c5 is 7c2, my dear friends, 7 into 3, 21, this is 21 is gone. So now your equation is 10 minus 3 power x into 3 power x is equal to 9. So you see, put x is equal to 2, one possibility, 9 into 1, or if you put x is equal to 0, also another possibility. For these two equations, the given condition is satisfied. Moreover, the first, third, fifth terms of the AP are what? The second, third, fourth terms in the expansion, the binomial coefficients, not simply binomial quotient means second 7c1, 7c3, 7c, you see, third is 7, second is 7c1, third is 7c2, next fourth is 7c3. You just find these three numbers will follow an AP. So the conditions are verified. There are two values for x, 2 comma 0, and for this logarithm is also defined. 10 minus 3 power x is positive only, here also okay, and hence, my dear friends, you can say sum of the squares of all possible values, you will get 4. 4 is the answer for this question. So dear students, I mean to say here, the first model, so just if you know binomial theorem expansion and little bit of algebra, you can comfortably answer the first model question, that is nothing but TR plus 1th term or binomial expansion. Then coming to second model, finding coefficient of x power m, I think you know the shortcut. If you want to find coefficient of x power m in the expansion of a x power p plus b by x power q whole power n. In this expansion, to find coefficient of, I mean to say, find coefficient of x power m, yeah, I mean to say, so suppose that coefficient appears in TR plus 1, there is a shortcut to find R, my dear friends. R is equal to NP minus M by P plus Q. So if you could remember this, you can save a lot of time. So this is the point. And if you want to find independent term or constant term or term without x, you have to treat M is equal to 0. so that R is equal to NP by P plus Q. This single point is enough to answer the upcoming questions, right? So here you can see in this model almost 30% of the question, 1/3 of the questions are based on finding coefficient of x power m only, which is the very important one, dear students. Now you see this question, the sum of the coefficients of x power 2 by 3 and x power minus 2 by 5 in the expansion of this. You see, dear student, try to find simple. The question is x power 2 by 3 plus half into x power minus 2 by 5. You can write 1 by x power 2 by 5 whole power 9 is the expansion. You want to find coefficient of x power 2 by 3. So how to find R, my dear friends? R is equal to NP. NP means this is P, this is N. So 6 minus M. M is nothing but you have to find coefficient of 2 by 3. NP minus M by P plus Q. Sum of these two, that is 10 plus 4, 10 plus 6, 16 by 15, which you will get. So this is 16, 18 minus 2, 16 by 3 by 16 by 15, you will get 5. R is equal to 5 means you just write the coefficient 9C5 into 1 to the power of something and 1 by 2 to the power of 9 minus 5, 4. So 9C5 into 1 by 2 power 4, which is one coefficient. Similarly, you need to find coefficient of x power minus 2 by 5. To find x power minus 2 by 5 coefficient, R is equal to NP is same, minus M will become plus 2 by 5, by P plus Q will remain 16 by 15 only. That is 32 by 5 by 16 by 15. 16 2 times, okay, 5 3 times. So this is 6, my dear friends. So R is equal to 6 means you will get 9C6 into 1 by 2 to the power of, see, 9 minus 6 will become 3. So sum of these two he is asking. That's it. That you need to find. You will get 21 by 4. Just simplification only. So to answer this question, whatever shortcut I have given, the same thing you have to apply 2 times. That's it. Okay. Right. The next, my dear friends. You see this question? Simple question. So all the questions that I am discussing here are PYQs only of JEE Main. PYQs of JEE Main. So do remember. So with the help of simple concept, we are able to answer the questions. The term independent of x in the expansion is 105. Find a square. So how to find, my dear friends? R is equal to NP is 20 minus M is 0 for independent term by P plus Q is 5, which is 4. R is equal to 4 is given. Try to write the corresponding term. 10C4 into root A to the power of 10 minus 4 into 1 by 2 to the power of 4. This is going to be, he said, 105. 105, right? So from this you need to find a square. That's it. Simple, my dear friend. 10C4 means 10 into 9 into 8 into 7 by 24 into this is a cube. You will get 1 by 2 power 4 is 105. So I think you can cancel 8 3 times, 3 3 times. Yeah, you can also cancel here 3 35. 35 2 times 70. So you will get a cube, this is 2 power 4. A cube is equal to 8. So a value is 2. Once you know a value is 2, you are going to get a square, which is 4. Hurry, to answer this question, simple. This technique is enough. R is equal to NP minus M by P plus Q. For independent term, M value is 0. So many students, so by seeing some complicated questions, difficult questions, lengthy questions, they feel like such easy questions will not come in JEE Main. Do remember, all questions will not be difficult in JEE. Okay. Next, dear students, you see, for two positive real numbers A and B, such that this condition is satisfied, the minimum value of constant term in the expansion of this. Same again, same kind of question. So what is this? A x power 1 by 8 plus B by, let me write, x power 1 by 12 whole to the power of 10 is the given question. In this constant term he has to find, so we have to minimize that. What is the constant term? Find R, my dear friends. Apply the same shortcut. NP is 10 by 8, which is 5 by 4, minus 0 by P plus Q, 1 by 8 plus 1 by 12. So 3 to 5 by 24. So you will get 6. R is equal to 6 in the sense you are going to get the corresponding term 10C6 into A to the power of 10 minus 6 into B to the power of 6. This is the constant term. We have to minimize it. Okay. He is asking the minimum value of this. 10C6 means anyhow you know 10C4, that is 10 into 9 into 8 into 7 by 24 into A power 4 B power 6. This is 8 3 times 3 here. So 210 into A power 4 B power 6. Now dear students, I have to minimize it. A, B are positive. The sum of these two numbers is given. Why can't I apply AMGM for this? Arithmetic mean 1 by A square plus 1 by B cube. For these two positive numbers, arithmetic mean greater than or equal to geometric mean. So x plus y greater than or equal to 2 root xy, 1 by A square into 1 by B cube. So now dear students, you can see this is given as 4 by 2, 2 greater than or equal to 1 by root of A square B cube. So root of A square B cube is greater than or equal to 1 by 2. So A square B cube is greater than or equal to 1 by 4. Its square A power 4 B power 6 greater than or equal to 1 by 16. So this particular expression's minimum value is 1 by 16. So your answer is going to be 210 into 1 by 16 is the answer. So you can say 4 if you cancel. So you can 2 if you cancel, 105 by 8 is the answer. 105 by 8 is the answer. Okay. So dear students, so we can do this question in this way. So in these models, my point is to say, dear students, if you just know how to find independent term or x power m coefficient, you can answer almost 1/3 of the PYQs of binomial theorem. Next dear students, sometimes the question may be given same coefficient of x power m, but in products it will be given. You see dear students here, the coefficient of x power 70 in, you see this product, this product, this product like this is given as 99 Cp minus 44 Cq, then what is the possible value of P plus Q? You might have done such kind of question. You want x power 70 coefficient in, you see x square into 1 plus x power 98 plus x cube into 1 plus x power 97 and so on. The final one would be x power 54 into 1 plus x power, you can say 46. You can observe sum is 90, I mean 100, 100, 100 everywhere. There are 53 terms. You can observe that it is a geometric progression where this is first term A and common ratio, you see x power is increasing by 1, its power is decreasing by 1, x by 1 plus x is the common ratio, number of terms is 53. So you can just apply sum of in terms of a GP, so that this will become A into A is x square into 1 plus x power 98, A into 1 minus r to the power of n minus 1 or 1 minus r by 1 minus r will become 1 by 1 plus x. Right. Now dear students, this becomes x square into 1 plus x power 99 multiplied by, you will get 1 plus x power 53 minus x power 53 by 1 plus x power 53. So you have to subtract 53 in this. If you subtract 53 in this, 46 you will get. Right. Now you just multiply, this is x square into 1 plus x power, this is 99 minus x power 53, x power 55 into 1 plus x power 46. This is what you got. You just want x power 70 coefficient in this. That means the total expansion is simply written in terms of these two. Now you want x power 70 coefficient, means already x square is there. In this you take x power 68 coefficient minus x power 55 is there already. You want 15 more. So you can take, this is 46 C 15 you can take. So the same he has given like 99 CP, 46 CQ. Of course P can be 68, or there is one more possibility. So you can say 131. Q can be, it can be 15, one possibility. Second one 131. Am I correct? Yeah. So Q has two possibilities, P has two possibilities. P plus Q, one of the possibilities. You just try all the combinations. Here you will get 68 plus, you see, 15. 68 plus 15 you will get 83. 83 is the possible combination here, dear students. Okay. So we can do this question in this way. So here same coefficient of x power n, but given like products. Next you see this question. The coefficient of x power 2012 in 1 minus x power 2008 into 1 plus x square power 2007, dear students. Here you know, dear students, 1 plus x into 1 plus, see, 1 minus x into 1 plus x square will become 1 minus x cube, right? So you do one thing, 1 minus x you separate one term, the rest if you multiply this will become 1 minus x cube power 2007. So that is going to be 1 minus x into, if you expand 2007 C0 minus 2007 C1 into x cube plus 2007 C2 into x power 6, like that you will get the last term. Now you have to multiply. If you multiply with 1, you see this is constant, all the powers of x will be multiple of 3 only. If you multiply with x, all the powers of x will be 3n plus 1, right? So if you expand in total, the powers of x will be either 3k type or 3k plus 1 type. But I just want coefficient of x power 2012, right, which is 2012 will be 3k plus 2 type. It is neither multiple of 3 nor 3k plus 1, 3k plus 2. That means such term does not exist in this expansion. So such coefficient is going to be 0, dear students. That's it. But anyhow, you can do like this. So this is also an important model. Then the next, find coefficient of x power 7 in the expansion of 1 minus x plus 2x cube whole power 10, dear students. So this is, we can say like multinomial theorem combination it is. I want coefficient of x power 7 in this. So to get, so you just try to write power 0 here. I want to get x power 7, 7 here. Total sum must be 10. Already 7 is covered, 3. This is one combination. The corresponding term will be like 10 factorial by 3 factorial into 7 factorial into 0 factorial. Coefficients 1 cube into minus 1 power 7 into 2 power 0. This is one term, dear students. The second one, you put 1 here so that x cube is covered. So I want 4 here so that x power 4 you will get. Total 5 is done, so you want another 5. So the corresponding coefficient will be 10 factorial by 5 factorial into 4 factorial into 1 factorial into 1 power 5 into minus 1 power 4 into 2 power 1. This is second coefficient. Similarly, if you put 2 here, 6 is covered. 6 means here you have to put 1 here. So that sum is 3, so 7 you have to put. The corresponding coefficient will be 10 factorial by 7 factorial into 2 factorial into 1 factorial, 1 power 7 into minus 1 power 1 into 2 power 2, right. Then next, if you put 3, the power it will be more than 7. So only 3 such terms will be. You simplify this expansion, this simplification, this simplification. Addition of these 3 will give you the coefficient of x power 7 in this. So my dear friends, we can say here third model is finding coefficient of x power n in products and other combinations. Okay, so 3 models are comfortably done. The next model, my dear friends, remainder model. This is 4th important model, which can be done very easily, and we have to do by using binomial theorem, but we can do in a direct way. The simple point is, dear student, to find the remainder. There are many questions over remainder also, dear students. So this number when divided by 21, what is the remainder? Simple thing, when the question is given in expansion form, so replace the base with the remainder. Replace the base with the remainder. So the base, you see, 428 power 2024. So 428 when divided by 21, 21 into 20 is 420, right? So here 8 is left in the denominator. So you can treat the problem like 8 power 2024. Always replace the base with the remainder. Now you read the powers of 8. So 8, for I am dividing with 21, remainder is 8. 8 square is 64. When divided by 21, 21 3s are 63. So I better write it as 64 power 1012. Now replace the base with the remainder. 64 when divided by 21, remainder is 1. 1 power 1012, the remainder is 1. That's all, dear students. Remainder is 1. Clear? Simple question. You see this question. What is the remainder when this number is divided by 9? Simple, bhaiya. The base you replace with the remainder. 64 when divided by 9, the remainder is 1. 1 power 32 power 32 is 1. So answer is 1. Very simple, right? The next, dear students, you see, what is the remainder when 7 power 103 is divided by 17? Okay, so keep reading 7 powers. 7 power 1 will give you remainder 7. 7 square 49. So yeah, you can write 7 cube 343. 343, actually 30, 17, 20s are 340, right? So 7 cube 343, I try to write it as 7 cube power 34 into 7. Can I write? Yeah. So next, 7 cube is 343. When divided by 17, the remainder is 3. So you can treat the problem like 3 power 34 into 7. Now start reading powers of 3. When divided by 17, for 3 remainder 3, 3 square 9, 3 cube 27, which is 10, 3 power 4 81. 81 means 85 is multiple of 17, 4 short of. So 3 power 4, let me write it as 3 power 4 into 8, 3 power 32 into 3 square into 7. You see, dear students, 3 power 4 is 81. When divided by 17, remainder is 4. 4 means minus 4, in fact. Minus 4 power 8, you can write 3 square into 7. The next step, since 8 is even number, I can write 4 power 8 into 9 into 7. Now 4 square power 4 you can write into 9 into 7. When 4 square is 16 divided by 17, the remainder is minus 1. Minus 1 power 4 into 9 into 7. So this is equivalent to, so 7 into 8, 63, right? Now if 7, now it is, you can easily divide with 17. So 12 means 12 is the remainder. You can say remainder is 12. So this problem can be done with the help of this remainder logic easily. Okay. Next question, dear student. You see, this kind of questions are very familiar. Fractional part of such number means simply answer will be the same number and numerator will be the remainder when this is divided by 8. 3 power 200, you can write 3 square power 100, which is nothing but 9 power 100. Replace the base with the remainder 1 power 100, which is 1. So 1 by 8 is the fractional part of this, dear students. So you will get 1 by 8. So in this way, you can also do the problems related to remainder theorem. remainder model. So altogether, dear students, we have discussed 4 important models in binomial theorem, which is, we can say, point number 1, simply binomial theorem expansion is sufficient to answer the questions. Second, so finding coefficient of x power m related questions. Third, finding coefficient of x power m in the product of certain terms, different kind of questions. Then fourth, you can say remainder model. So almost you have covered 75% of the models of PYQs in binomial theorem topic. Now the left out topics also I will try to highlight, dear students. Sum of all the rational terms in the expansion. There are 5 questions, previous questions. So you know, first, how many rational terms will be, he is asking the sum. If number of rational terms is asked, there is a shortcut. You just see when will you get rational terms. 2 power 1 by 5, 5 power 1 by 3 powers I am going to talk. So bases are anyhow prime. So here you have to put multiples of 3. If you put 0, you have to put 15. So 15 by 5, this is okay for us. Then if you put 3, you have to put here 12, will not work. If you put 6, you have to put, or you can try with 0, 5, 10, 15. This is bigger denominator, that combination also works. So you can also say, dear students, okay fine, anyhow, if it is 6, you have to put here 9, will not work. If it is 9, you have to put 6, will not work. If it is 12, you have to put 3, will not work. If you put 15, 0. So there are only 2 terms, my dear friends. Here power 15, here 0, this. What is that combination? 15C0 into 2 power 1 by 15 power 15 into 3 power 1 by 3 whole power 0. This is one combination, which is nothing but, this is 2, 1 into 2, this is nothing but 2. Second combination is 15C15 and 2 power 1 by 15 power 0 into 3 power 1 by 3 power 15, my dear friends. So you will get here 2 power, this is 5, sorry, if this is 5, 2 cube, this is 8, and here 3 power 5 you will get, this is 3 power 5, okay, this is 3 power 5, 81 into 3, 243 plus 8 you are going to get, my dear friends. So simplification you have to do, dear students. The sum of all the rational terms in the expansion of this, the only possibility is 2 combinations. You can also try like here 0, 5, 10, 15. Those terms you have to simplify and do, dear students. Okay. Next, you see the number of integral terms in the expansion of this. There is a shortcut for this, you know. For bases are prime, the shortcut is divide the power with the denominators of the fractions. LCM of these two, 2 and 6 LCM is 6, and step off this plus, if either of these two divides 824, you have to write plus 1. Suppose neither of these two divides, you no need to add anything. So you just see, my dear friends, this is going to be step of 1. Yeah, so 137 point something plus 1. So 137 plus 1, there will be 138 rational terms in this, dear students. You know, this is the standard question, important model, we can do this. Okay. Next, dear students, you see, yeah, A denotes the sum of all the coefficients in the expansion of this. Then you see, another one, here one expansion is given. We can say these are properties of, simple properties of binomial quotient related quotients. You know, my dear friends, what are the simple properties of binomial quotients? You know, I mean to say here, I'd like to say simple properties in the sense binomial quotients are C0, C1, C2 and so on Cn. So you must recall NCR is equal to NCn minus R. Second, if NCR is equal to NCS, you must get either R is equal to S or R plus S is equal to N. And third, you can say if NCR plus NCR plus 1, if you add these two, dear students, you will get N plus 1 CR plus 1. I am just recollecting all the important points, dear students. The next NCR by NCR plus 1, this is very, very important in this chapter. You will get R plus 1 by N minus R, right. Similarly, suppose NCR by N plus 1 CR is given, N is one more in the denominator, N plus 1 minus R by N plus 1 is the result. The next, my dear friends, you can also say, yeah, NCR can be written as N by R into N minus 1 CR minus 1. For example, 10C4, you can write 10 by 4 into 9C3. Okay. So, these are simple properties related to binomial quotients, and apart from these, C0 plus C1 plus C2 plus Cn is nothing but 2 power n, the sum of all binomial quotients. And if you take only even suffixes, C1 plus C2 plus C4 plus and so on, will be equal to sum of all odd suffixes and so on, whatever you will get, this will be 2 power n minus 1. So, these are the basic things. And if you are given 2x plus 3 by x square whole to the power of some 11 is given. If you want sum of all binomial coefficients, dear students, sum of all coefficients, if you want to get, you take it as f of x. If you put x is equal to f1, f of 1 will give you sum of all coefficients, and f of minus 1, if you put, dear students, now combination of these two, f of 1 plus f of minus 1 by 2 will give you sum of coefficients of only even powers of x, and f of 1 minus f of minus 1 by 2 will give you only sum of coefficients of odd powers of x. These points are minimum required points to answer certain questions related to the problems having simple properties of binomial quotients, right. Now, dear students, you just see this, yeah. So, capital A denote the sum of all coefficients in the expansion of 1 minus 3x plus 10x square whole power n. Sum of all coefficients is capital A. Array, sum of all coefficients in expansion means simply put x is equal to 1. If you put 10, this is 11 minus 3, 8 power n. He named it as A. Next, B denote the sum of all coefficients in the expansion of 1 plus x square whole power n. In 1 plus x square whole power n, sum of all coefficient means again f of 1, which is, you can say, 2 power n. He named it as B. What is the relation connecting A and B? You see, B cube is nothing but, this is 2 cube whole power n. So, B cube is nothing but A. So, A is equal to B cube is the answer. To answer this question, hi. So, dear students, to answer this question, what you need is simply sum of all coefficient means f of 1, that is it. The next, dear students, you see this question. This is a very, very important model, I have seen this kind of question in 5-6 times in PYQs. What is this? Sum of coefficients of 3 consecutive terms of binomial expansion 1 plus x power n plus 2, they are in the ratio 1:3. It's very, very important model, friends. Suppose this n plus 1 is some m, suppose. You see, dear students, yeah. हम तो 16 मिनट में कंप्लीट करने के लिए बताए, सो इसलिए थोड़ा 2 to 5 मिनट्स दे सकते हैं, लेकिन वो अलग सेशन में, ये सेशन थोड़ा रैपिड सेशन है, थोड़ा फास्ट से करना है, इसलिए हम थोड़ा फास्ट कर रहे हैं. ओके नितिन, चले करेंगे क्या? थोड़ा फास्ट करेंगे. फाइन, ओके नितिन. या सो एक क्वेश्चन देखिए, द सम ऑफ द कोएफिशिएंट्स of 3 consecutive terms. You see, suppose these are like 1 plus x whole power n, suppose instead of n plus 2 you suppose n, no problem. Chalo, sum of, you see he is asking about the ratio of 3 consecutive binomial quotients. हम NCR minus 1, NCR plus 1 ले सकते हैं. Let us take like this, given the ratio is 1:3:5. Okay, so here from this you need to find n and r. So n and r means you do one thing, NCR minus 1 by NCR will give you 1/3. So what is this? There is a formula just now I told. So n same r one more in the denominator, r by n minus r plus 1 will be 1/3, which gives one linear equation in n and r. 3r is equal to n minus r plus 1, which is equal to 4r is equal to n plus 1 is one equation. Second equation ये होता है कि NCR by NCR plus 1, NCR by NCR plus 1 will become 3/5, dear students. So here the result is r plus 1 by n minus r will be 3/5. So you will get 5r plus 5 is equal to 3n minus 3r. So that 8r is equal to 3n minus 5. So you solve these two equations, dear students. Correct. Yeah. So you solve these two equations. So 8r, no, this is 2n plus 2 is equal to 3n minus 5. 7 is equal to n. Correct. So n value becomes 7. Once n is equal to 7, r is equal to 2, right? R is equal to 2. Now dear students, you can say what is n here? In this I have taken this as n, NCR minus 1. This becomes 7C1, this becomes 7C2, this becomes 7C3. Okay, he is asking their sum. That's it. You can just do the simplification. 7C1 is 7, 7C2 is 21, and 7C3 means 7 into 6 into 5 by 6, 35. Okay, 36, 46, 56 and 63 is going to be the answer. And this model, dear students, yes, you are correct. This model, I appreciate Nitin, superb, done, well done. So my point is, dear students, so this model is a very important model. Even though there is a shortcut, A is to B is to C, we can remember, but than this is a very easy one. So what you need to answer this particular question is, dear students, do remember NCR by NCR plus 1 formula is going to be r plus 1 by n minus r, dear students. This is enough. Next dear students, after that you see sum of the coefficients of first 50 terms in the binomial expansion of 1 minus x power 100. Okay, how to do this question, dear students? You see, actually suppose the power 100 is there. So say you will get C0 minus C1 plus C2 minus C3 if you take and so on plus C100. This, you know, dear students, is going to be, I simply in this expansion I put x is equal to 1, RHS is this, LHS is 0, dear students. Now there are 1, 0, 1 terms. I want sum of coefficients of the first 50. So can I write it as C0 minus C1 plus C2 minus C3 and so on minus C49, odd suffixes mine, plus C50, then minus C51, let me write here because these two are same, like that this will be C100, this will be minus C99 plus C98 minus C97, like that I can arrange the sum. Okay, the sum can be arranged like this. Now I just want this sum, dear students, sum of coefficients of first 50 terms. Now you know that these two are the same because NCR is equal to NCN minus R. So the required expression is R, these two are same. So 2R is nothing but minus C50, dear students. So R is nothing but minus 1 by 2 into C50, correct, dear students. So but the options are not like that. You see, 99 C49, C50 means 100 C50. Just now I told a property, dear students. This is minus 1 by 2 into 100 by 50 into 99C49 you can write. NCR can be written as n by r into n minus 1 C r minus 1. These two get cancelled. So, the answer is minus 99C49 is the answer. Minus 99C49, which is going to be option C, dear students. This is also a question related to binomial coefficients. So, properties of binomial coefficients. You see, I have taken the total expansion. I need the sum of all first 50 terms. Got it, dear students? Nitin, how do you feel this question? How is the question? How is the solution? Comfortable, cool? Nitin? Yeah, perfect. Right. See, dear students, after this you can say, so some more question. The mean of coefficients of, you see, yeah, x, s, it is easy question that you need to just do simplification. The mean of the coefficients of x, x square, x power 7 in the binomial expansion of 2 plus x whole power 9. So, in this expansion, dear students, so the point is, so you can write the expansion and you will get sum of all coefficients is going to be 3 power 9. So, you just want the coefficient of x, you will get coefficient of x as, you see, 9c1 into 2 power 8 into x you will get, plus 9c2 into 2 power 7 into x square, and so on, 9c7 into 2 power 2 into x power 7. You want this sum, dear students. You want this sum 1, 2, like this. Of course, you want their average, mean. There are 7 terms, you have to divide it by 7. So, now, dear students, so this you can write the total coefficients is going to be, this is 3 power 9 minus, you can remove the rest of the terms, which is 9c0 2 power 9 plus 9c8 2 power 1 plus 9c9 2 power 0 by 7. You just simplify this, you will get the answer. Okay. Yeah, answer you can check, you can do the simplification. Okay. Right, dear students, you can do this question in this way. Fine. Yes, perfect answer. Nitin. So, simplification only. I mean to say, here also what you need is simply binomial quotient, simple points. The next, dear student, you see this question. Now, purely binomial quotient related. Yeah, the 10th session, would it be BT only? Yes. No. First session is binomial theorem and second sessions will follow 10 different topics we are going to discuss. Okay. Swaran Srivastav. So, first session is binomial theorem. So, next session, yeah. क्या Swaran? Yeah, चले करते हैं. You see, NCR denotes the binomial quotient of x power r. Okay, क्या है यहाँ पे? So, 1 plus x expansion. You just see the properties, dear students. I think this is sigma k is equal to 0 to n. To expand this, what you require, I will give the central idea. This is 2 square into ck plus, I guess this is 3k into ck. You need to apply sigma. If you apply sigma to this, sigma k is equal to 0 to 10, and you are going to get, dear students, 2 square into k is equal to 0 to, suppose n is given, this sigma ck, sum of all binomial quotients will become 2 power n. This is, I need to say, k into ck, we have formula. That means here, dear students, I mean to say, dear students, here k into ck, you can see like, you see c naught plus, I mean to say 1 into c1 plus 2 into c2 plus and so on n into cn. I think you know this. This is the standard one. This by taking derivative will get our n plus 1 into 2 power n minus 1. So, I mean to say here, this is going to be, you can write n plus 1 into 2 power n minus 1, and this is going to be 2 power n. So, this you can take n is equal to 10 and simplify, you will get the answer. My point is, in the binomial quotients, the questions are many questions, dear students, but of those, a few questions are, only a few are important, few are getting reflected. Let me recall those, dear students. That is derivative based, that is 1 into C1 plus 2 into C2 plus and so on n into Cn. We can say like sigma r into Cr. Sigma r into Cr will become r is equal to 1 to, this you will get n plus 1 into 2 power, yeah. So this is going to be, you can say, yeah. So even in the previous also, you see, actually 1 and so on, no, this is n into 2 power n minus 1, not n plus 1, this is n into 2 power n minus 1. This you will get by taking 1 plus x whole power n is c naught plus c1x and so on cn x power n. You take derivative on both sides, put x is equal to 1. Okay. The next, dear students, if you take the second derivative, if you want alternate plus minus, put x is equal to minus 1. Then second derivative if you take, this will become 2 into 1 into C2 plus 3 into 2 into C3 and so on n into n minus 1 into Cn. You will get n into n minus 1 into 2 power n minus 2. This is one result. The next, dear students, most important, this is r square into Cr. Sigma r square into Cr, of course r is equal to 1 to n. You will get r square into Cr, you will get n into n plus 1 into 2 power, n minus 2, n into n plus 1 into 2 power n minus 2, okay, right. So for this what you need to do is, here after taking derivative multiply with x and then again take the derivative, you are going to get. These results are important. Apart from this, dear students, you can also try certain questions related to binomial quotients here which are given. And my point is, so many are saying that in binomial theorem, binomial quotient related questions are not there. So that syllabus is not there. But in 2024, you can find the questions related to binomial quotients also. Please recall the important properties related to that, dear students. And then you see here also, to answer this question, here n is 20, r square 20 Cr is given. R is equal to 0 is fine, it becomes 0. Then again, so r square 20 Cr, you just require the property sigma r square into NCr. Okay, dear students. So in this way, we can say here also AR by AR minus 1, NCR by NCR minus 1. We have property for NCR minus 1 by NCR, right? NCR minus 1 by NCR will become R by N minus R plus 1. Its reciprocal is asked. So you will get here R cube into, you will get N minus R plus 1 whole cube by, you will get R square. It gets cancelled with R. Now if you put expand R is equal to 1, you will get, my dear friends, like AP kind of. Okay, here 1, 2, 3, 4 other things will come, and you can also replace n minus r plus 1 here, you can do this question. So my point is, among the properties of binomial coefficients, yeah, here, so all together out of 120 questions that are there in PYQs, the most important thing is just TR plus 1 binomial quotient related, there are around 20 questions, x power m coefficient 30 questions, x power m coefficient in the product one more 20 questions, and remainder model around 20 questions. 70% of the questions are occupied by those 4 models only. You just work on it very strongly, and other areas also you cover, so that you can 100% attempt the question from binomial theorem, which is very easy, dear students. So stay tuned to Sri Chaitanya, stay tuned to Infinity Learn. So we will be discussing 9 more topics, important topics from where you can easily grab marks in JEE Main. Okay, dear students, that's all. Take care. Bye. See you.